Hi guys, I'm picking up where I left off. I actually kind of goofed up on that. You know, these touchscreen gold iron newfangled phones, I'm telling you, I'm really feeling like an old timer. I gotta set this down. I'm gonna be really careful not to touch the screen. You touch the screen, I keep forgetting that the screen on a smartphone is one big giant button. It's a control surface. And I don't mean a rocket fin when I say control surface. Okay, here we go. With a little bit of machining and a lot of patience, this is the kind of person I am. Let me direct this here. I keep pointing it in the wrong direction. These guys actually started out as Schedule 80 2-inch couplers. I'm sorry, 1.5-inch couplers from Home Depot. They were literally 90 cents a piece. Now, okay, this is part of the under $14 charge. These motor tubes, they came in one bulk length of 2-inch ABS, one bulk length of Schedule 80 PVC, and these two couplers, these are PVC couplers. They were Schedule 40, which means their wall thickness was approaching 1/4 of an inch. Now look how far I machined them down to. I used the belt sander, and I did this before, before it was set up for the shoot. And I'll tell you what, again, I'll assert one plain simple fact, folks. In aerospace and the rocket building and design, or in building an experimental aircraft, I'm warning you right now, it's not the materials that are so expensive. It's not even equipment and tool expense and setup. That can be long-term expensive as well. Where you're going to be hit is your time. It's always labor intensive. The single biggest expense in aerospace, especially rocket building and anything having to do with rocketry, sounding rockets, data rockets, high altitude research rockets, or my own very first micro launch vehicle. I'm actually going to plan on putting something up into space. I have an idea how to do that. I do not have an idea how to recover the rocket after I've done that. So I am going to need help on that project. The 15-foot tall 4-motor monstrosity. The point is, everything is labor intensive. For these two couplers, I had to spend no less than an hour and a half, almost 2 hours, 1 hour on each coupler, and I'm thinking there's got to be a better way to do that. On this belt sander, I had to sand them sideways. I had to set up this gate, and the thing is, this gate is plastic, so I had to square things up. Over time, as it's warped and worn out a little bit. Look at my lovely hands. Oh my goodness. Boy, that scares me too. When I had to square sand this surface, I had to square sand the underneath the surface. I had to retrofit the washer underneath the adjustment knob. I'm actually using two washers, so it's like a slip joint instead of a fixed joint. You can clamp down on one washer and you turn it, and it's metal on plastic, it'll chew up the plastic underneath. So you have to space them out with two washers. So the top washer turns on the bottom washer, the bottom washer stays still and doesn't chew up the plastic. I spent about half an hour on that, square checking. Remember, right angle here and right angle from here to here. Right angle from here, this vertical surface and that vertical surface, and a right angle here from that surface to that surface. You need at least two right angles to effectively square sand some type of tube or aluminum tube or square stock if you want a right angle end. And that's really important in rocketry because you don't want to build crooked airframes. I'll explain that later. I'm getting too much into advanced model rocketry building right now, and that's bugging the heck out of me. So anyway, so that's that. But again, I'm going to steer away from this double fuselage rocket by just saying I did have to actually spend literally almost 1 hour on each one of these couplings. 1 hour for this coupling, 1 hour for that coupling. Patiently standing there until my back started giving out and aching, machining these down. The wall thickness started out that much, and I reduced it that much. And now, when I started getting thinner, I suspected I need to check the fit. And I went back and forth checking the fit nearly 6 times on each coupler, and it fit too tight, so I'd run it in and then back it out and sand it and make sure it fits a little looser. By the way, backing up, I did have to glue these two tubes together. Then I had to saw them and square sand them. By the way, guys, make very, very sure you cut all your rocket tubes, motor tubes and fuselage tubes in single units and measure and sand them and match them up that way. It's not really a good idea to bunch the tubes up together and then try to square sand the two tubes together. For whatever reason, it's just it's much more difficult. You have to square sand You have to measure, cut, and square sand and even up the length of each tube individually. And this is really sounding like an advanced rocket building, but Jesus H. I think I'll just label that tonight. We'll get to setting up the shop tomorrow. That's the only thing I'll do. I'm really going off on a tirade, and I think I know the direction this video needs to go. So, okay, so now I'm going to change my mind. See, I'm Jason Wampler. I'm a hybrid monkey engineer, and I do that. I change my mind mid-pitch. Okay, so what was I saying? Okay, when this is two group glued together and then glued to the fuselage with cyanocrylate. The same thing with that. When you do double mambo, when you do a double up on the fuselage, if you want to try this design, it is experimental, so I'm not sure how it's going to turn out. But I've always held to the axiom that any idea is a good idea as long as it's well engineered. So, and I'm a hybrid monkey engineer. Okay, so but that wasn't it. You see the interior diameter of this ABS. Look at that. That looks like a honed bore. Looks like a honed cylinder bore in an engine. And I'll tell you what I had to do. For whatever reason, I always have good luck using a hole saw instead of a drum sander. A hole saw always works better. You get an even, consistent texture, and interior. Let me get that real up there and let that focus. Where's my camera anyway? You can't really see it. Well, you can see where it ends. The dark part of the tube that suddenly begins. There you go. You kind of see the details now. Well, this phone, the camera really works. It's autofocus, but I think it's confused because it didn't know what the heck it's looking at. There you go. I get an even, consistent turning. All I have to do is put sticky-sided sanding disc for my sander, and I have to just wrap, because it has that adhesive, and then just wrap it around a circle saw, which is a hole saw, which drills holes to a certain size bore. In this case, 1.5 inch or 1 1/4 inch hole saw, and then just go inside the inner diameter, swirling like the phone is swirling. Don't get dizzy, don't get hypnotized. That is time number 2. And it works out great. I kept doing it about 2 or 3 times each hole until these couplers, slipped in those holes. And hooray. About 3 or 4 hours later, I have couplings that fit very, very tight, keep the body straight, and just look excellent. I mean, I'm very, very happy with the way the work turned out. Smooth, sanded surface. Again, I'm definitely going to sand down and paint this rocket. I'm not going to use a block sander on the sides of this rocket. I'm just going to do it by hand. Remember, 320 grit, then 420 grit sandpaper. Then you have to buy your primer and paint together, because the primer is critical that the primer is compatible with the paint, which means it has to be the same brand and the same type. I go with Krylon, but whatever is available and relatively affordable at Home Depot is what I go with. Crown Ace Hardware has a good paint selection too. The Crown Ace Hardware that was in Costa Mesa, for whatever reason, it shut down. They lost their lease. But I do believe it may have something to do with the downturn in the economy due to the COVID-19 pandemic. I'm just kind of wiping my nose here. It's running a little bit. It is starting to get really cold, and I kind of don't like that. Okay, so here we go. But I'm so jazzed about this. Again, guys, you can get materials for a rocket that go to the very, very outer reaches of the Earth's atmosphere and the stratosphere, and you can literally buy the parts for the rocket for pennies on the dollar. I mean, relatively speaking, it's not cheap. It's not expensive either. Again, I must stress and emphasize this. I guess tonight is advanced model rocket building. It's for all ages, but it's intended for college students, engineers, and scientists. And I want to give a shout out to all the weather chasers in this country. Hey, my name is Jason Wampler. I'll leave you all my contact information. I can build a sounding rocket for you for a fair price, and we can get together, do airframe integration of all your electronics, and I can build them up to. Right now, I can facilitate a rocket up to 20 feet in length, about 8 to 10 inches in diameter. But it's going to be a monster. You have to pay for it because there's value added. But anyway, that is a quick plug-ola, and that's shameless. I shouldn't be doing that. I'm not a capitalist pig. Or am I? Okay, but I'm so happy about this rocket. Mostly I'm happy about the fact that I didn't have to use pins or tubes to join the two tubes together. Okay, so one important point. Again, I must assert the biggest expense in building a rocket is not the money on the materials or not the money spent on tooling. That's a big long-term expense. It's their time. Guys, this was a quick build, but I got to tell you, I built this in one day, all this in one day. It's now probably past 10 o'clock. Close to New Year's Eve. Well, it is New Year's Eve, close to New Year's Day. But the thing is, in my past, I've been building rockets for 20 years. I've never been building stuff of this size and scope. I did build one rocket called the Blackbird, but I set it out in the alleyway because, I believe I discussed this before, I was having logistical issues with it. Where am I going to get material for the motor tubes? Where am I going to get the money to buy the propellant grain? It was a huge 2-engine rocket. It looked, aesthetically, it looked beautiful, and I'm sure it would have flown fine, but I just, construction methods, how to mount the motor tubes to the side of the central tube. I didn't know how to successfully attach things. And I know that the rocket body itself, the design, the concept with 8 fins, the 3 tubes on the side and 2 on the side. It had 8 fins, and I'm sure, and they were beautiful. They were swept clip delta front and rear, and they were beautiful. I had the leading and trailing edges sanded down, aluminum ribbons at the base, peg posted into the fuselage. I had everything flush and lined up. I just didn't have the knowledge to know how to build motors that big and set up tube attachment. It was my first 2-engine, 3-tube rocket, and I just parked it out in the alleyway, and I came back literally about 30 minutes later, and it was gone. It is gone. I hope it's in the Air and Space Museum, and it hasn't been launched by some fool and killed somebody, but that's possible too. I don't like the thought, but I know one thing about that rocket. If I had flown it, I put engines in it that are big enough to lift it, the payload, electronics, and everything, it probably wouldn't have got off the pad. The motor tubes would have just broken free and shot off freelance by themselves, because I only had them cyanoacrylated to the center fuselage, and you can't do that. A rocket that big and that heavy and that fast and powerful, that won't work. So again, I'm going to label this class advanced model, what is this, class number 2, advanced rocketry and team building rocketry. The purpose of this rocket is, it is the last day of the year 2020. It's December 31st. I believe there's 31 days in December this year. I did want to have some fun. But the reason for these motor tubes and this size and everything, I want to try out the double fuselage assembly. I glued everything together. Important note, I'm not just leaving this the way it is with the cyanoacrylate. Cyanoacrylate is fine, but it's a crystalline-based type of adhesive. I'm going to have to go over this and fill everything, all the gussets lengthwise, with low-profile, somewhat reduced epoxy because I can't rely on cyanoacrylate, which is super glue. Super glue and cyanoacrylate, it's crystalline. It's brittle. It breaks like glass underneath stress. It doesn't really affect the PVC. But I have to tell you, these motors are going to be roughly 20 inches, about 18 inches tall themselves. They're going to be 30 millimeter in diameter, comfortably at 30 millimeters in diameter, and let's just say 16 inches. 4 16-inch motors, 30 millimeters in diameter, interior diameter, that is. I am going to run what's called hot rod chromite fuel in it, and I'll tell you right now, I'm not going to espouse on this because the motor building class is for Saturday, and I'm going to hold off on discussing propellant formulations because, guys, I can feel your men and women alike, ladies and gentlemen, I can fill your head with all sorts of crazy ideas, and guess what? Suddenly, I'm getting blowback on the internet because somebody blew off a couple of their fingers in their hand and lost an eye, or somebody's kid is in the hospital with a missing arm because they decided to watch my age-restricted video on Saturday regarding concept and design of solid rocket motors. And I don't want that to happen. I have to be honest with you guys. Again, YouTube does offer me an option of restricting that video to 18 and older. I have to figure out how to make that 21 and over once we start actually mixing the propellants. And the other thing is, I am here at the parking lot at Estancia High School in Costa Mesa, California, United States of America, planet Earth, etc., etc. I cannot mix and test light propellant formulas on a high school, public high school parking lot. I can't do that anywhere in Orange County. So now, all right, I just numbed my toe. So now I have to figure out very carefully another venue where I can do that. And again, not in Orange County. There's certain parts of Riverside County I can go, but then again, I still have to be careful because test firing these rocket motors, to be honest with you, test firing the propellant is one thing. And you can't find out, you're not going to be able to figure out things like if it's an explosive or it's a high burn rate ablative. You want something that's an ablative that burns really quick and generates a lot of pressure. You do not want something that explodes in confined spaces even when it has a nozzle. But I'll discuss that on Saturday. Saturday we're going to be all talk, and then we're discussing motor design concept. And I'm actually going to start cutting and fitting the motors for this rocket. So on Saturday I'm going to concentrate on it again. I have to get to the 4-engine monstrosity over here because I'm retrofitting the attachment system so I can just tunnel things out without going out there with a huge, $60 diamond hole saw and a modified extension on a drill. I don't feel like spending all that money and then putting a slip tracker or radial slip tracker behind it to keep it from digging into the sides of the fuselage. But again, actually, that is going to be a subject for next week's discussion, which on advanced model rocket or advanced rocketry and team building rocketry. That will be Tuesday night at 10 p.m. So all these classes, all 6 classes are in excessive order every night at 10 p.m. Now I'm coming up on a 16-minute mark. I said I'd cut it off at 30 minutes, and that's it. So we will discuss on Saturday fitment of the motors in this rocket and their ideal size, because guess what? I have some tube stock that will fit, and then again maybe I don't. Oh, hold on, let me come over here and check the size of this red motor tube. I'm thinking this might be ideal. The anodized extruded aluminum tube T6061 that I get from Industrial Metal Supply is just a bump. There it is, man, and I almost have enough to make 4 motors. That's going to be a tight fit. Well, in all honesty though, I don't want this rocket motor to be overpowered because I do not want this to be a high altitude research rocket. I actually want this thing to go no more than 3,000 or 4,000 feet. I want to keep an eye on it and observe its characteristics, its flight characteristics, because it is a double fuselage rocket. Let me put the 2 halves back together so we can get a view of the full length. Again, folks, the biggest expense in rocket manufacturing and rocket design and engineering and manufacturing, etc., is always going to be the labor. Now, this rocket, total labor is 1 day. That's record time, which indicates to me exponentially rockets get more time-consuming and complicated and expensive based on their size. You go from a 10-foot tall rocket, that'll take me 6 months to build, to a 20-foot tall rocket, that'll probably take you about a year and a half to build. And a 50-foot tall, very, very small launch vehicle, that'll take a team of about 50 to 100 people, almost 2 years to build and launch. I mean, it's just crazy. The labor and time involved in custom fabricating these launch vehicles, including my micro launch vehicle right over there, the 15-foot tall 4-motor monstrosity. I'm so excited about, and the rest of the projects I'm working on. They're just going to gobble up your time. I think the lion's share of what's gobbling up my time and taking so long is I'm learning various construction methods and tooling and equipment. I'm returning a lot of tools to Harbor Freight and other places I've got them from, including even O'Reilly's, because I just don't use these tools. I can't use them. There's no practical application for them, and you have to hold the tool with one hand while it's an attachment for a tool you have to hold in the other hand and pull the trigger, and then somehow you have to hold the subject as well that you're machining. And there is where the third arm in the middle of your chest comes in. But I've already debated that with myself and you guys too. Please hit the subscribe button and phone in some suggestions. I need a third arm growing out of the middle of my chest. What do I do now? Okay, so I'm really, really excited. But look, guys, again, what you want to go away from after tonight's episode or lesson or session or whatever you want to call it is this. Be prepared to spend the time. Now, I'm going to show you how to save all sorts of money, keep costs down for your mobile manufacturing facility. I'll even show you how to set up a fixed facility, but I can't do that now only because I don't have a fixed brick and mortar facility. So everything is laid out and clean. It's not a high school parking lot. It's so well lit and it's so sanitary and serene, and no one's bothering me. So I like being alone when I teach, but eventually I'm gonna have to work out someone with my friend and cameraman Ulysses Andrades. Shout out to Yuli. Yuli, please don't do anything to injure yourself by your crazy behavior with fireworks. We all know you're crazy with fireworks, sir, but you're an excellent machinist and my good friend. And I friended Ulysses Andrades on Facebook. Ulysses Andrades is a good, full-hearted, spirited, soulful man. So, and he's my friend, that's why. All right, so anyway, a shout out to my father, Clinton Samuel Armstrong. Shout out to Scott, Jake, and Dinah Hyra. I hope you guys are going to be home tomorrow from Big Bear, because I'm going to be really lonely and upset if you're not. Let's see, a shout out to who else? Don Williams or Williams Landscape. I actually texted you this morning, Don. I hope you got that. Shout out to my friend Paul Sprangel. Paul Sprangel, you are struggling with your family. You know, I understand. There's something else I want to talk since tonight's class number 2 about advanced rocket building. Okay, so I mentioned this, but I'm going to repeat it for emphasis. Look, you guys, your combination belt face sander is essential. This saw is essential. You're going to cut sections, of very, very large sections of ABS or PCV, depending on the application. Now, I have to warn you about something. You do need these tools. And the other thing is you need to convert this rip saw or arbor saw. You need to convert this to a chop saw as well. This blade is kind of small. It has a very shallow cut radius. I believe it's only a 10-inch cut radius, so that gives you 5 inches on both sides, minus the arbor what do you call it, washer carousel. So you really can't cut much. I'm going to show you how to roll and cut at the same time and even up the square up the edges with the saw blade itself. A special technique, but the reason I'm talking about this, about cutting tubes, because this is tooling. This is explaining the tooling and why you need it so much and what it does. Now, you know, when you square cut the end of a large diameter motor tube, like the ones I'm using, a 6-inch diameter motor tubes over there on the Jolly Green 15-foot tall 4-engine monstrosity. Again, there's a special way to cut. If your saw is not big enough to cut all the way through the fuselage, you have to carry it. You have to support it on the back end, because 6-inch diameter PVC in an 8-foot section, I gotta tell you, that weighs upwards about 50 pounds. So you have to have somebody holding it behind you. They have to understand it has to rest square and level on this surface. It has to be square and level and straight on this surface as well. What irritates me about this dang saw is it has a bunch of angled ramps on it. I have no idea what the purpose of that is. But square in the gate on this side, but it's angled on that side. The problem is I'm right-handed, not left-handed, so I come at it from this side, not that side. If I came at that on this gate, which works great, from this side, I simply have to be back behind this saw to do that, because I'm right-handed. I handle things that way. But then, this does have release buttons on both sides. These are interlock buttons that are close to each other, and then you press that down. But the thing is, the saw is not going to stay on when you leave it, when you release your grip from the trigger, and that's a problem. So I really need that third arm attached to my middle chest. Guys, anybody in robotics and aesthetics, give me a shout out. This is Wampler, class number 2. Please hit the subscribe button, but I'm begging you, I need a third arm growing out of the middle of my chest. Either that, or I need an assistant somewhat of the feminine, lovely female human variety who wants to maybe even be my wife. I shouldn't have said that. I'll keep shut up now. Okay, we're now into 24 minutes, 30 seconds. I think I'm going to dump the other video. To be honest with you, I'm still getting used to smartphones. The whole screen is basically one big giant button with a bunch of buttons underneath. It's a control screen. The static discharge from your bioelectric energy, the electricity that actually runs through your body, it actually keeps your nervous system alive and keeps your heart pumping. It discharges at a range of approximately a little bit less than 1 to 1.5 millimeters. And you don't even have to touch the phone to hit a button, and all of a sudden you're looking up cruises for your animal. Somebody's sales pitching you on a brand new Tutti Frutti dessert making machine, and you originally just wanted to keep shooting your video on advanced rocketry and team building rocketry, and it really makes you upset. But I'm getting used to it. Okay, let's start closing up shop. I gotta be honest with you, at this point, I'm kind of trailing off of my energy. I'll look at the time. I'm maybe going to continue building after this a little bit longer. In fact, I kind of think I will, because I think there's some other stuff that I want to do. I don't want to engage in a large-scale project. I kind of want to see what else I can do for this guy, because this guy is interesting. I'm having a lot of fun with that. I whipped this whole thing together in one day, which makes me wonder if I'm going through an extreme learning curve, and that's why I'm so hung up on these other 4 projects. That's why they're so strung out and taking so long. I've never built a 15-foot tall rocket before with 4 motors, not 2 or 3. So that's a first. So I'm going through a learning curve on that. So guys, I'm admitting my own guilt. This is advanced rocketry, team rocketry, and I'm admitting the fact that I've never built a rocket that big. Kind of makes me look like a newbie hypocrite. I've built other rockets that big, the turquoise one, and the one next to it almost that big, and the 5-engine rocket. This rocket, again, I build rockets this size all the time, so, and I'm fairly comfortable with it. So anyway, my name is Jason Wampler. I own a company called Wampler. We build advanced rockets for scientific research, sounding rockets, and even micro launch vehicles, and we enjoy what we do. I forgot to mention this. I'm also the founder of Red Hal Rocket Society. It's aimed at furthering the pursuit of advanced rocketry. It's open to everybody and anybody, but to be honest with you, I'm not really interested in those little micro rockets anymore. I did have an interest with them. It's more for college students pursuing their degrees in engineering of some facet or another, and scientists and engineers already in the field themselves. You're welcome to show up. I know a lot of you designers and engineers working for large or major rocket building corporations. I know you guys got the bug to do your own side project. Hey, I want to tell you, brother, I'm here for you, or brother or sister, I'm here for you. So, on that note, we're at 27 minutes and 37 seconds. I do have to use the little boys' room at this point, so I'm going to call it quits. Anyway, Jason Wampler, founder of Red Hal Rocket Society, in the high school, Estancia High School parking lot, Costa Mesa, Orange County, California, United States of America, planet Earth, solar system, Milky Way galaxy, but I suspect everybody who's going to watch this is going to be in the relative vicinity. Anyway, good night. We'll talk to you later.